Hi, so thank you very much for the invitation to speak today, first of all. I am going to talk about a project I've been involved in for the past 5-6 years now, which is, I'm mostly going to speak about the Clairvaux manuscripts, the manuscript from the Abbey of Clairvaux, but the overall project is very much about the biocodicology of manuscripts. I think my talk was a bit ambitious. I have 4 parts I'd like to talk about, so I think the fourth one is more like a little bonus, if I see I have enough time to discuss it. So the very first part is I'm going to explain to you what biocodicology actually means, what we do and how we do it. Then I'll talk about the identification of the materials in the making of the books, like specifically medieval manuscripts. Then I'll talk to you about a project we're working on at the moment, which is trying to explore the provenance and the origin, of manuscripts. And if I have enough time, I'll talk about deer skins, and I'll explain to you what the relationship between those chapters are. There is a link, don't worry. Maybe some of the details are going to be a bit technical, but it doesn't really matter. Like there is a story behind, and if you don't really understand the diagrams, it shouldn't really affect the understanding of the overall talk. So what is biocodicology? Well, first of all, I want to talk about codicology. Very often when we speak about codicology, we think about the way scribes were writing the texts in the manuscripts, so the way the writing was set on the page, mostly the way everything was prepared on the parchment. But what I really mean by codicology is the book itself, the binding, so the structures, the way the pages were put together, and the materials. So I don't really look at the texts. I look at the materials that make the book. And I'm mostly interested in medieval binding, so Carolingian and Romanesque. So 9th, 8th century up to the 14th century. So I'm sure everybody knows already what a book looked like in the Middle Ages, but I just want to remind you that the way a book is made is a long story, and that's why it's so interesting to look at the way things are put together. I look at the structures to show you what we can actually learn from it. So what I'm looking at is still the codex form of the book. So, you know, like this book with quires. And when I talk about the bindings, what I actually mean is the set of operations which give a book its final form and by which it is protected with a rigid or flexible cover for both protection of the book and embellishment. So it's not just what we see outside, it's all the different elements that make the book. So this is a picture of quires. So like the very first codices were made with several bifolios that were folded and inserted into one quire. So you can see at the top, it's like the very first form of quires. So like a notebook in a way. Just one quire would make a full codex, and very quickly we started to make codices the way you see at the bottom of the page. So several quires of fewer bifolios. So you have your quire made of several bifolios that you put together. That's called the text block. That's something I'm looking at. Then you're going to sew the book on sewing supports. So I put a little video for those. Oops. Just a little video just for those who might not know how you make a binding. So this is my colleague in Trinity College rebinding Carolingian manuscripts around sewing supports. Then you have the board lacing. So you have wooden board that you're going to attach to the sewing support. So that's also something I'm looking at. And then you have the covering, and all those elements together are called the binding. Now, I really, really want to talk about the way the quires were made. So everybody probably knows what parchment is, but just to make sure, because I'm going to talk mostly about parchment afterwards, I just want to tell you that for most of the bindings from the Middle Ages in Western Europe, the block text is made of parchment, and parchment is animal skin, and you have this large sheet of parchment that you're going to cut, fold to make those quires. So it's pretty much a mechanical process for most of it. So liming is chemical, obviously, but then fleshing, deliming, stretching, scraping, pouncing. There's no tannage. That's important because it has an impact on the biology of the material. So that's just a couple of pictures from Dick Timmerman that we probably know as well. So who just got the skin from the butcher, removing the flesh as much as it can. Then you have the liming bath to remove the hair. This is us with Élodie preparing parchment. You can see the dehairing. So again, there is sound to show you the mechanical process. So that's also a movie from Dick Timmerman. So you can see the action of dehairing. I'm not going to leave it too long, but it's just to show you like the removal of the hair. And then stretching. So the parchment is actually made of collagen, and this collagen is actually very interesting for biocodicology, for the study of the material. So here is Élodie stretching a skin, and that's pretty much almost ready for writing, pouncing, scraping to prepare the skin. Anyway, all this is just in case you didn't know about this, but just to tell you that for the very first manuscripts I studied in Clairvaux, which are really, really large, you pretty much need one animal per bifolio. So when you have 200 bifolios, you need pretty much 200 animals or 100 animals. And in the Middle Ages, at that time, each herd had about 40 to 50 animals in the herd, and only maybe 35 cows, 11 male, and only 70% of the cows would give birth to one veal, one little calf. So you'd have about 2 to 3 of them who would actually die at birth. And on top of this, you can only kill about 30% of the newborn or young-born male animals. So you get about 6 animals you can actually kill out of one herd. So you'll have about maybe like 5 animals per herd that you can actually use for parchment. Which means, oops, sorry, going too fast. Whoop. Sorry about this. Yeah, so you get 5 to 8 animals per year, which means you need about 13 herds to make one manuscript, which is huge. I mean, I don't know if you have an idea, but in Clairvaux, for example, they don't have 13 herds of like to make a manuscript. They don't have 13 herds of calf to make a manuscript. And if you want to make 5 manuscripts a year, like they would do in Clairvaux, you would need about 65 herds. So what I mean by this is, it is, oh, sorry about this. Oh. I'm sorry. Yeah, so you would need about 65 herds, which means it's quite interesting to study the manuscript because you can get a lot of information about how they would be made. That's one thing. How the monks would organize themselves to make these manuscripts, and you can also get a lot of information about the management of animals in the Middle Ages. So biocodicology is about studying this parchment I was just talking to you about. So biocodicology is the study of the pigments. We can do DNA, we can do proteins analysis, and we can look at the microbes. So for the project I'm working for, Beast2Craft, we don't look at the pigments. It's not really what we're interested in. We're more interested in DNA, proteins, and microbes. And it's really about getting biomolecular information to tell us about the history of the manuscripts or of the animals in the Middle Ages. So it's really, we're working together with conservators, historians, biologists, and also zooarchaeologists who are interested in the animals. With biocodicology, you can do several things, but there is the biomolecular aspect and the visual aspect. So in terms of visual, you can look at the production, scrape marks, repairs, surface treatments, and you can look at the dimensions of the animals, the follicles, disease. But with biocodicology, you can look also at the proteins and the DNA. So proteins is good to study, to identify the species of the parchment, of the leather. You can also identify surface treatments, stains, and with DNA, you can look at the parchment. You can also extract human DNA, so that's a different story. And you can look at the microbiome at the surface of the parchment. And I'll explain later what you can get from this. It's pretty much, so what we're using is a non-invasive sampling techniques where we use rubbings from an eraser that is used for conservation, for surface cleaning. And with the same sample, we can do either proteins or DNA analysis. So except that for DNA, you need a little bit more. So I usually take enough for DNA, and so I can do both analysis at the same time. But it's about the same thing. You have extraction, purification, analysis results with different techniques. The big difference is that proteins is a lot quicker and cheaper, and DNA is going to take a lot longer and is going to be a lot more expensive, although it's much cheaper than it was even 7 years ago. So we're about £500 average per sample. So it's not cheap, but it's much better than it used to. Okay, so here is a table which shows you what you can get from those techniques. The animal identification, the species identification can be done by e-zoom analysis and also DNA. And you can do it on parchment, tan leather, alum toad, pretty much. But with protein analysis, you can't really get the microbiome, you can't really get the sex of the animal. There's a few things you can get, but it's cheap and you can identify the species. So it's something we've been using a lot. And we can also do the PQI, which is Parchment Quality Index, which we think is showing the amount of time the skin was left in lime, the way I showed you at the very start. Lime being very alkaline, and the role of the lime is to help dehairing the skin. There's different techniques to dehair. There's lime or there's putrefaction, but anyway, so it really gives us an idea of the manufacture of the parchment. So it's quite interesting. I'll show you some examples. So now I've told you what is biocodicology. I'm going to give you an example of my project. So that was my PhD project, but I also worked on it as a postdoc after my PhD for the past 2 years, and I'm still working on this at the moment. I've been working a lot on the library of Clairvaux for a very good reason. Is first of all, I was a conservator for the collection in the Montpellier University Library like 10 years ago. And it's a very, very big collection of manuscripts that was stored in the Abbey of Clairvaux until the French Revolution in the 18th century, and was confiscated and brought to the library, the public library of Troyes. So most of the manuscripts, except for some, kind of just stayed in the same place, which makes it really easy to study. It's really nice when you have lots of manuscripts. It has a very high rate of preservation. If we look at the catalogue written by Jean de Voivre in 1472, you have about 62% of the 15th century collections that's still in existence today in different collections, with a very high proportion in Troyes and a smaller proportion in Montpellier, but it gives me already just only 2 collections to be able to study quite a lot of those manuscripts, more than 1,000. And what's even more important is that about 50% of those manuscripts are still in medieval binding. And most of them are intact. So I had about 351 bindings that were not conserved, that were in their original state. And about 150 were Romanesque bindings. So in Clairvaux, you don't really have Carolingian bindings anyway, but there is a very, very large collection of Romanesque bindings, and I think it's the largest collection, Western collection of Romanesque bindings known to date. So it was very interesting to study this collection because we didn't have a study of that size so far. And about 60% of them were made in the Abbey. So it was a very good opportunity to study French Romanesque bindings at the time, see which ones were made on site, see if I could find some patterns. And it's also a good opportunity to see what was done elsewhere in France, and all this in the same library. So fascinating collection. So the questions I wanted to ask were if this Romanesque collection was representative of the French production of the time, or if it was a typical Cistercian practice, not just French Cistercian, or if it was a very local craft signature in Clairvaux. And I wanted to see if we could see, looking at those bindings, at those objects, if there were any evidence of cultural and commercial exchange or local production and supply. And to answer those questions, biology is quite useful, even though you wouldn't think. But I started to, the way to answer those questions was to do as if you would, like the way you would do when you study a text, and try to see if I could find hands, different craftsmen. So not looking at the text, but looking at the tool marks, looking at the parchment, looking at the way the covers were made, looking at all those different elements, see if I could also find some different hands, see if I could identify a timeline in the bookmaking, so helping paleographers to date the manuscript. And I had to find a method to answer my questions without actually looking at the text, because the text can't really give me any answer. So that's a bit boring, but like I had to make a database, set up a terminology. I left it in French because I worked in French. And the conclusion is it didn't work. I couldn't make a timeline. I could see hands, but the overall conclusion is there was monastic production that wasn't a bookbinding, specialized bookbinding production. You have different people working on the same bindings, and the bindings would be moved from one person to the other. I don't know if it was very complex organization or if it was a bit random. Whoever was free first would take it, but you'd have the leather craftsman, probably the person making saddler. For the wood, I believe it was very likely the person making wine barrel. And for textile, it looked very much like maybe clothing or curtains, or like you had different techniques. It's not the purpose of the talk today, but just to give you ideas of what you can get by just looking at the object and looking at codicology. And I could also identify other bindings that were made outside of Clairvaux in proper workshops in the 12th century. So that's very interesting because we used to believe that there was no workshops, like professional workshops, lay workshops outside of monasteries at the time. And we can see that in Paris it's starting. But anyway, there was other categories like amateur bindings at the time as well. Anyway, what was one of the ways to classify those books was also to look at the materials. So that's really the purpose of this talk today. And most of the bindings that were made in Clairvaux that I was showing, that were brought from one craftsman to the other craftsman, they look like those. So they're quite large, and they're made of two leather covers. One very thin sheepskin underneath the white little bit you can see here, and on top a hairy cover. And the big question was to know what these covers were made of. And in catalogs, medieval catalogs, you have some descriptions. In the 18th century, we're told it's either wolf or bull skin. And the 20th century, catalogers are starting to think it's more likely to be deer or roe deer skin. And I don't know if everyone knows about Bert van Regemorter, which is one of the very first codicologists working in the 50s. And she looked at the bindings from Clermarais, so not Clairvaux, but they look very similar. And she said that in her opinion, it is deer or roe deer skin. So I kind of assumed that's what it was, even though at the time she didn't have any microscope, she didn't have any, she just had her eyes and the book in the library. So obviously maybe she was not right, but I assumed she was. So how do you identify animal skins when you work in the library? Just by visual examination, while you look at the skin, the follicle patterns at the surface of the skin. So I'm not going to give you too many details here, but it's just to give you an idea. You just look and see if you have little groups, little patterns of follicles. Calf skin has no pattern. Sheepskin has patterns with primary, secondary hair follicles and their little groups. Goat skin has some little lines with primary and secondary hair, and pigs has like 3 follicles grouped together. Anyway, so that's kind of how you do it. And most of the skins are usually covered with, most of the bindings are usually covered with domesticated animals. So I brought those with me, so little samples to compare. But I also brought with me some deer skins and boar skin, just to see if I could find out. So you can see here on the left, the deer skin under the microscope. I use a little Danolite, a little microscope that I can plug in my computer just to look. I look like 30 times magnification is enough usually to look at the follicle pattern. And if you go a little bit closer, around 300, you can see the little pattern on the hair. So it's quite interesting. And as you can see here, on the left, it is deer skin, and on the right, it is the Clairvaux skin. Okay, it's very damaged, but it's clear it is absolutely not deer skin. Excuse me. So I knew that in 2014, some of the hair were sampled on the Clermarais skins, which is very close to the bindings of Clairvaux. Again, I said it already, but just to remind you. So they took 4 manuscripts, they sampled the hair, and it was looked at under magnification, and they said it was probably calf or horse, I think. Yeah. Definitely not roe deer or deer, but DNA would be necessary to confirm. And the reason is that when you only look at the hair, you can't see much. Anyway, it's not enough. You need to look at the hair on the skin and look at the different, as I explained, the patterns of the follicle as well. So it didn't really work. So I thought, great, I'm going to try, since I have DNA and proteomics, I'm going to try and see if I can confirm It is calf, although I don't believe it is. So I took a few samples from Clairvaux because that's what I was interested in, and I also took Clermarais to be able to, see if it matches. Even though I was pretty sure it did match looking at it under the microscope, but to confirm with biology. So there's two techniques we can do, as I said: proteomics, proteins, and DNA. Proteins is cheaper, so we will do this first, and you can identify the species, which is mostly what I wanted to do, and it's cheaper. So we did this first. So it's peptide mass fingerprint, and as I said, we use this technique of eraser, which is an electrostatic sampling. That's Sarah Fidemans who developed it, called e-zooms. It's micro-invasive, which is good, so you don't really take much. It's only loose fibers of collagen that we take at the surface of the skin. It's a bit like this with electrostatic sampling. I've put the little link. I don't know. I can maybe give it to Evelyn at the end, so you guys can click and have a look at the full technique. And we did this fingerprint of the collagen, and every animal has a specific fingerprint, the way we do with our fingers. So calf would have a different fingerprint than sheep and than goat or deer skin. And what we found out was that it was actually seal skin. So for French people, it's quite surprising because we didn't have any in the Middle Ages on the French coast. So anyway, it raised a lot of questions. So I went back to my collections, and once I knew from biology it was sealskin, I was able to identify sealskins on many other bindings just looking at it under the microscope using forensic analysis techniques. So there are several things you can look at, which I didn't know before because I didn't know what I was looking at. But once you know, it's easy. It's a bit like a doctor. Once you know the symptoms, it's easier to find the disease. So like it was about the same. I knew what I was looking for. It was easy to identify the skins. So like, yeah, there's different things you can look at. There's a bit like tagliatelle hair. They're very flat, and you have the primary and secondary hair coming out of the same exit. So there's different follicles inside, but there's only one exit for all of them. So that's one of the patterns. Anyway, so it means that all those bindings from Clairvaux were actually covered with hair like this. But I just want to highlight that Cistercians in Clairvaux, I was very surprised that they would have brown bindings like this. So I looked a little bit more into it, and the brown color of the skin is actually what you can see on the bottom right of the screen. It's actually the layer. So you can see there's white and brown because I scraped the fat at the surface of the skin. So the brown color is actually the fat at the surface of the skin. The skin is actually white, and the hair was actually not like white, middle-aged white. So like clear color like this. This is a little sample I got anyway online from Canada, and it was a little seal toy from the 70s. I really wanted this one because it's undyed and it's tanned the exact same way as they would have done in the Middle Ages. So and you can see I shaved a little part of it, and you can see it's brown. I don't know if everybody can see that. So you can see the brown color is very similar to what we see now on the bindings, but it was actually much clearer, like you can see here on the beige hair. Anyway, I looked at more of the collections, and I could see that most of the bindings in Clairvaux of this exact period were covered with chemise, and most of them were actually sealskins. So And then I looked elsewhere in Europe. I looked at the daughters of Clairvaux, all the way to Bruges, actually, and even further up to England. And all the daughters of Clairvaux I went to look at had sealskin. So in Bruges, it's not all of them, but lots of them also are made of sealskin. And you can see, so there's a few, like Saint-Amand, for example. I'm not sure where the bindings come from because it was reused. The Lincoln Cathedral, there's no identification, no paleographical identification of the origin of the binding. But I went and looked at it, and it really looks like Cistercian binding. Looking at the codicology study tells me this. And all of the other ones are also daughters of Clairvaux. So I can't, of course, you never know what you can find. But at the moment, I believe this is probably a Cistercian technique. So this is what a seal looked like for French people in the 13th century. We didn't have a word in French. We used only the Latin word. So I suspected, just for the little story, that maybe they were a bit fooled and they had no idea what they were buying. I don't know. Anyway, DNA. So from this, my colleague Matthew Teasdale, who's doing ancient DNA, DNA is ancient DNA, tried to do some DNA on the samples as well, to see if you could get a little bit more information about them. Because you can get also species ideas, but we already knew what they were. But you can go further down into the different breeds and sex potentially. But so same technique, same sample, gone for DNA analysis, and we did get quite a good depth of coverage. So this just shows you that each samples had different quality. That's pretty much what it is. So we had very good ones and some that were not as good. And we were able to go a little bit further down. So not just say it is sealskin, but we can say what kind of seal. So we had harbor seals, great. But we had also a couple of harp seals and bearded seals. And those were mostly seals from Greenland, obviously. Harp seal and harp seal were from Greenland. So we have a colleague in Copenhagen, because the Vistacraft project is Cambridge, Copenhagen, and Paris. And in Copenhagen, we had this colleague who's only working on seals, medieval seals. And so he had a very, very big database. And we were able to compare the genetic information he had from ancient samples and modern samples and all samples. And with this, we were able to have an idea of the geography of the origin of the skin. So seals are moving, but we could compare it to things they had found in excavations. So we have some of the samples are coming from Greenland, some of the ones from Iceland, Sweden, the north of England and Scotland, and a lot from Denmark as well. So I thought that was interesting because there's no mention of the sealskins going through the Hanseatic trading. But we can see that the samples are from places where the Vikings were stopping. So I can't be sure that it really comes from them. But we have a text from the Pope at the end of the 13th century in Rome, asking his administrator, what on earth are we going to do with all those sealskins that the Vikings are giving us to pay for their tithe? So I believe they were sealskins circulating very likely from the Vikings and being traded all the way down to the Champagne fair and reaching maybe the Cistercians in Clairvaux, or it was coming from the church. And you can see that at the end of the 13th century, I have to rush, I don't have much time. At the end of the 13th century, There's no sealskins anymore on the collections of manuscripts. And this is matching the time when the Vikings, or the Norse, sorry, in English, the Norse, were disappearing from Greenland due to a change in climate. It became really, really cold. They didn't manage to survive with their techniques of hunting, and therefore they slowly disappeared. And you can see the skins are not present on the manuscript. Is it linked or not? I don't know, but it just happens to be at the same time. So that's the Inuits working the skins the way, I think it's the same technique because we can only find oil in the tannage. Anyway, number 3. So I think I won't have time to do number 4, but it was just in case. Number 3, following this, we decided, okay, that's very interesting. It looks like with DNA, we can maybe find out where the manuscripts are coming from. So the good thing, I don't know if it's, I don't know. Okay, we'll see. So in Clairvaux, it's again a perfect collection to check this. So with the sealskins, it was easy because they're wild animals. With other animals, it's not always as easy. So I decided to resample collection in Clairvaux, some that were made in Clairvaux and stayed in Troyes, some that were made in Clairvaux but went elsewhere, some were made in Paris but came to Clairvaux, and some that were from elsewhere and came to Clairvaux. And, you know, try to have like a large range of manuscripts from everywhere. And see if the parchment and the leather were actually traded with someone else, because you remember I showed you that you need 65 herds to make 5 manuscripts, and there are not enough farms in Clairvaux to make to have all these animals available. So clearly they must come from elsewhere, but I just wanted to prove by biological analysis that it was true. And see if the parchment by folios were of the same origin, if the sheepskin covers were of the same origin. And to do this, we just wanted to compare groups, like to differentiate groups in the manuscripts using biology. So like groups of DNA, groups of proteomics. So when it's about like sheep, it's been done. I put like an article here that shows like they've been able to look at the breeds and more or less say where they come from. Now you can't tell if it's from Troyes or the little village next door. You know, it's large regions, but it's good. But what you can also do with DNA analysis is this. You can look at the metagenome at the surface of the skin, so the microbes and the bacteria. Sorry. And so we had done this with the sealskins, and Matthew found 2 groups which were not, that we were expecting to find the harp seal in one group, the bearded seal in another group, and harbor seal in the other group. But it didn't it's not what he found. He found groups that seem to be Clermarais and Troyes. So the red ones are Clermarais and the blue ones are Troyes, Clairvaux. So the thing is, in my samples, there were way too many variables. So we needed to kind of see what actually we were seeing here. And so what we're doing at the moment is I resampled everything the way I told you, took 80 samples, and I tried to change one variable at the time to try to see if I can see, like, you know, separate the origin, the provenance, and then the storage, like the recent storage, and try to see if I could see any difference. So what we got was pretty good. I said that probably means nothing to any of you, but it's, believe me, the average genome coverage with ancient DNA when you're above 2, it's excellent. And you can see here that we get up to 9, which is almost like brand new human DNA. So it's probably a lot of metagenome, but that's what we're looking for anyway. So we're still in the process of studying this. But we also decided to do the same with protein analysis. So same samples, we took the same things, and we look at not just the collagen, but all the proteins in the sample. And we have a super great program that, and a very good also IT scientist in the team who managed to develop this tool that groups the proteins by similarities. So when they look more alike, they're grouped together. And we can see with the covers that you have the ones from Paris on one side and the ones from Clairvaux on the other side. So it seems like it's working. For the parchments, it's not working the same, but I expect it is. It's all mixed up. So we're still in the process of looking at this, but it looks like the parchment was coming from too many places to be able to group them, unfortunately. But you can still see that, thank God, the same manuscripts are in the same group. So we took samples of the same manuscript, different pages, so different animals in the same manuscript, and they're very close together. So that's a sign that the protein clustering is actually working. And then we did the PQI, which is the Parchment Quality Index, developed by our colleague Bharat Nair. And this shows that, so on the left it's the covers, on the right it's the parchments. And you can see, so there's a lot of calf skin, obviously, in the parchments, because that's what I was looking at. But you can see the groups of quality. So you can see the Clairvaux parchment, higher quality, the Paris much lower, the parchment from Paris that belonged to Prince Henri is also quite high quality, but less than Clairvaux. And you can see we tested Panthéon as well, just to have a look. But like this is also in the process of being done. Okay, that's something else. Okay, so I don't think I have much time for the deer skin, so I might have 3 minutes. Let's try 3 minutes. So the question we had is, okay, now we thought we were looking for deer skins. I'm going back to my initial point. We knew we thought we were looking for deer skins, and we found seal skins. So Sarah did analyze a binding that was made of deer skin. So she asked me if I had ever seen any deer skins. And my answer was no, I've never seen any, but maybe, you know that technique of identification I showed you when you look under the microscope at the hair follicles at the surface of the skin? Well, sometimes those are not visible. So I thought that maybe I didn't see it. Maybe I just wasn't able to identify the skins. But yeah, so Charlemagne did give rights to monks in the 8th century to hunt deer and roe deer to actually cover manuscripts. So they must be somewhere. And I thought maybe they are mostly covering Carolingian manuscripts. So that's what I'm doing at the moment. And I looked at the Cambrai skins, which is another project we're working on. And onto the skins, they look like this. I'll go to the conclusion really quickly. And you can't see, you can see the follicles, that's under the microscope. So you can guess, but you can't really see. And that's because the full grain is gone and you only have the corium, so you can't see anything. So we used e-zoom as well, and we found lots of deer and roe deer skins. So I'm just going to go to the conclusion. I checked Orléans. We found mostly deer skin, roe deer skin, 1 sheep. Saint-Armand, same bindings, same story. Deer skin, roe deer skin. Saint-Gall, I'm going to pass because it's not really representative. But anyway, that's the conclusion, is that we finally found those deer skins. No, I can't identify it by eye because of the process of making them, but they are there, and that we can only tell thanks to biocodicology. Thank you very much for your attention. I hope you have questions. I hope it wasn't too many diagrams.